A Portland Community College Mathematics telecourse. A course in arithmetic review produced at Portland Community College. Let's examine two different ways of saying or representing these shaded in portions of these three wholes. Well, first, we could say that each whole is subdivided into 6 parts. So that we've agreed on the last tape is the bottom or denominator of a fraction. Then the top represents how many of those subdivisions are shaded or taken. In this case, 6 more, just 12, or 13. But one could just as well have said, I have 2 wholes and 1 out of 6 parts of the third. Instead of using the word and, we could have used 2 plus 1/6. And if we do this long enough, we finally make an agreement. Since we know that the plus is there, we will by agreement quit writing it and just put 2 and 1/6 in that manner. These are different ways of representing the same number. If we write it this way, we call that a mixed number. And by mixed number, we mean it's 2 numbers mixed together. See, we even say it that way, 2 and, second number coming up, 1/6. This we call, unfortunately, an improper fraction if the top is equal to or greater than the bottom. That's sort of too bad, because in many instances this is a better way of saying it than this. This, after all, is a single pure number. See, we even say it that way, 13/6. This is not a single number. It's 2 and 1/6, hence the name mixed number. This lesson then reminds us that an improper fraction can also be written as a mixed number, or vice versa, a mixed number may be expressed as an improper fraction, and a student should be able to go back and forth as it's convenient. So let's concentrate on the improper form. Recall from the last tape that this fraction bar not only means out of, but it means divided by. So this could be read as 13 divided by 6. So let's do just that. 13 divided by 6. And doing that division, 6 goes into 13 twice. 2 times 6 is 12. We have a remainder of 1. Now, rather than writing the remainder as a remainder, we'll write the remainder as a numerator and the divisor as the denominator. So we have a mixed number form, an equivalent form for the improper fraction form, 13/6. A very simple procedure. Let's restate that more formally for your notes. To change from improper fraction form to mixed number form, just remember that the fraction bar also means divided by. Do it, and express the remainder as a numerator and the divisor as a denominator of a fraction. Let's do a couple more just for quick practice. Here we have 2 numbers expressed in improper fraction form. Let's change them to the mixed number form. All we need to do is recall this fraction bar means divided by. So we simply do it. 16 divided by 7. 7 goes into 16 twice. 2 sevens is 14. Subtract, the remainder is 2. So I write the remainder over the divisor. So 2 and 2 sevens is a mixed number way of saying 16 sevens. See, same thing here. 31 divided by 9. 9 goes into 31 3 times. 3 times 9 is 27. Subtract, remainder of 4. Write the remainder over the divisor. And we have that 3 and 4/9 is the mixed number form of the improper fraction form 31/9. It's just that simple. Let's try this rather simple verbal problem. Doris says quarters. She has 53. How many dollars does she have? Now, do you realize that in this problem, the dollar is considered to be the whole, and the quarter is what divides the dollar. And that dollar is divided into 4 equal parts called quarters. Therefore, to write these words in mathematical symbols, we get first that the whole, the dollar, has been divided into 4 parts. And furthermore, Doris has 53 of those parts. But now this is an improper fraction which can be changed into this division problem. Doing that division problem, 4 goes into 5 once. 4 goes into 13 3 times. Remainder of 1, which I write over the divisor. And this says that 53/4 of a dollar is 13 whole dollars and 1/4 left over. So the answer to our question is, how many dollars does she have? That's the whole number part, the whole bit, which is $13. Now there's a key here that will help you in future more complicated story problems. See, what we really did here was to translate the words into a math statement. This is saying with arithmetic symbols exactly what the word said here. Then by rewriting the arithmetic symbols in a different form, that different form answered our question for us. So it wasn't so much a matter of how to do the problem, but how to say the problem with math symbols. And as it turns out, the math symbols will give you a clue as to what to do. Remember this for future problems. It will be a very useful mental device. And as you begin to learn tricks for translating from English to math and math to English, you will find that the fraction bar means many, many different things. So this is a particularly good lesson to begin to store up a vocabulary of what they do mean. For instance, we've already learned in the last lesson that the fraction bar means parts out of. Sometimes it means simply parts out of period. Sometimes it means in. Like if I say 3, I mean 3 pieces in 5, just another way of saying out of. And in this lesson, we're learning that the fraction bar means the phrase divided by. So begin to develop for yourself a small vocabulary dictionary of what this, and then of course later other math symbols mean. And that will help you to go from words in later story problems into math, where interestingly enough the math itself will tell you how to do. You won't have to figure out what the procedure is in the problem, as in the case we're presenting to you in this lesson. See, you never need worry that if I'm going to do this division, which one to divide into which. You simply read it, remembering that the fraction bar means divided, not divide, not divided, but divided by. Catch the whole phrase. So if you read this, it simply says 45, next divided by, next 12, and see, there can be no confusion about what you're doing to what, because as you read it, mark for mark, there can be no confusion. So now dividing it, and of course since the top is larger than the bottom, we call that an improper fraction. So following through on the division, as indicated by the symbol itself, we would get 3. 3 times 12 is 36. Subtract, we have 9. So we have 3 wholes with 9 parts out of 12. Then of course you probably remember enough of your fractions to realize there's another form of this called the reduced form, which we'll get to in another lesson. So we'll stop here for the time being. So 3 wholes and 9 parts out of 12. So see, here we're using this, the meaning of this fraction bar as parts out of, 9 parts out of 12. Here we read this as the phrase divided by, so that we know exactly what to do in what sequence. This will be a large clue to later math, particularly in algebra, in being able to learn what the symbols are really saying. Then you say what the symbols are really saying, and surprisingly enough, you'll find that the math symbol is telling you what to do. We see an example of this in this particular problem. First, realize that this nomenclature-wise would be called an improper fraction. For some reason, many students believe that an improper fraction is one in which the numerator is greater than the denominator. Not so. It's one in which the numerator is greater than or equal to. So this is called an improper fraction. In the last lesson, we just told you that this seems logically to be equal to 1, because if you take 26 parts out of something divided into 26 parts, you've grabbed the whole, and we symbolize whole by the number 1. But you now see, if we read this fraction bar as the phrase divided by, then read it back to ourselves, 26 divided by 26. Of course, we know that is 1 with no remainder. So again, many times it will be convenient to remember that the fraction bar, among many other things, means the phrase divided by. So you see, this lesson and many others within this course ultimately reduces to a single type of problem, or 2 or 3, or a single type of objective. So if you can form a type problem and verbalize one problem absolutely correct all the way through to the end, you have a good, strong foundation for the rest of the lesson. So in this particular lesson, it's to realize that when the numerator is greater than or equal to the denominator, we call this an improper fraction. A very unfortunate choice of words, because frequently this form is more useful than the form we're about to change it to. So our type problem for this lesson is to change an improper fraction into its equivalent mixed number form. And equivalent means the two will have the same value even though they might look different. And the key idea for this lesson is to read that dash as a symbol, simply saying the phrase divided by. And we emphasize in this lesson, do not remember it just by the word divide or divided. It's the by that keeps everything in order for us. Because now all we need to do is to read the problem and write it down in a different form. 41 divided by 13. And there's no question about what to do now because this is directing us to our next step. So we can see that 13 goes into here about 3 times. The remainder is 2 over the divisor. So this improper fraction form has an equivalent form in the mixed number 3 and 2/13. So here in a nutshell is the entire lesson. The main point of each of the next few lessons is just that simple. Try to see that point clearly. However, towards the end of this unit on fractions, we will encounter a few lessons new to most of you, which will involve a great number of steps. Up to now, and for a few lessons yet, most of our lessons we hope are merely review for you. But we will encounter a lesson soon that will be brand new to most of you and will involve a great number of steps, not just 1 or 2 points like this particular lesson. But the many steps are nothing more than material which you have already had in the last unit of study, chapter 2 of your textbook. That is, the material over prime factorizations and its use in finding a least common multiple of several numbers. Do you recall that lesson? It will be very, very important that you do. That you not only vaguely recall it, but that you are perfect and very smooth and fast with it. Therefore, let's spend the last few minutes of each of the next few easy short lessons in review of those particular skills. Therefore, to get started with that review here, do you recall what a prime number is? It's not only important that we know that, it's absolutely necessary. Here we have all the natural numbers written up to 50, and of course the list goes on forever. But recall that some numbers like 2 and 3 and 5 and 7 in the first row are different from the others in that you cannot divide any of them evenly by anything except itself and 1. Those we called prime numbers. The other numbers, 4, 6, 8, 9, 10, we could divide by another number other than itself or 1. We can divide this by 2, this by 2 or 3, this by 2 or 4, this by 3, this by 2 or 5. So in the last lesson, we developed a partial list of prime numbers, which consisted of these numbers I'm now circling. And the reason we said a partial list is because just as the natural numbers go on forever, so does the list of prime numbers. And recall that we mentioned that these numbers are so important that most handbooks, math handbooks, will have a long list of prime numbers somewhere within them. And if you look at the backs of your textbook, so does it. And using a partial list of prime numbers, in the last chapter we gave you problems such as this. To prime factor, in this case 2025. Do you recall how to do that? it will be not just important to a later lesson in fractions, it will be absolutely necessary. So let's use this list of prime numbers and prime factor this number as a review. And recall we simply started a series of divisions of the number we wish to prime factor, but dividing only by primes. So starting with the first one, we ask, will 2 go into this? The answer is no, because this is not an even digit. Then we ask, will 3 divide into this? And so our divisibility test for 3 was to add the digits. So 2 and 2 is 4 and 5 is 9. If 3 goes into the sum of the digits, it goes into the number 2025. So 3 will go into this number, the prime number 3. So dividing it, we get 675. Then we ask, will 3 still divide the new quotient? Well, using the divisibility test again, 6 and 7 is 13 and 5 is 18. 3 divides that. So 3 divides 675. Doing that, we get 225. Will 3 work once again? So we stay with the same prime divisor until it will no longer go into the last quotient. In this case, 3 goes into here, 75. Again, we see that 3 will still go into 75 25 times. So we checked our first prime number 2, it would not divide, 3 would, and we stayed with 3 until it would no longer divide. Then we try the next prime, and of course it quite obviously will. And we continue this process until our final quotient itself was a prime. So our claim now is that 5 times 5 times 3 times 3 times 3 times yet another 3 is equal to 2025. So we have factored this, because factoring means to write as a multiplication problem. So we have factored this into a stream of factors, each of which is a prime number. That was what we called prime factorization. Now, to write this in exponent form, we're going to have first a 3, and there's 1, 2, 3, 4 3's being multiplied together. So we have 3 to the 4th times 5. There are 2 5's being multiplied together. So this number, 3 to the 4th power times 5 squared, is simply another way of writing that number. And this other way of writing this we call prime factorization. The process of doing it we called prime factor. So if you had difficulty with this in the last chapter, as part of this lesson, review a few problems until finally you have this thing absolutely nailed down and you're very comfortable with it. You simply give yourself a list of prime numbers, and usually these first few, which in most cases is all you need, will simply be memorized. Then you begin a process of repeated divisions by only prime numbers. So we can see that the first one, 2, will divide, but it won't anymore. But in this case, we see the second one will, and it will again, until finally I get a prime quotient. So my prime factorization of 54 is 2 times 3 times 3 times 3. But rather than saying 3 times 3 times 3, we can say 3 to the 3rd power. Isn't that easy? As easy as it is, this will be of prime importance at working very difficult problems in just a few more lessons. Specifically, we're going to use it in order to find a very systematic way of adding or subtracting fractions which have rather messy denominators. But if we are very successful at the review we're going to do over the next few lessons in the last few minutes of each lesson, when we get to this supposedly tough problem, you're going to find it's very easy and very routine. However, after the review, don't forget the main point of this lesson itself, because we will carry this over into the next lesson. So in this lesson, we recognize that we have an improper fraction. For whatever the reason, we want it as a mixed number. So we read this as 55 divided by 6, and we simply do it. So 6 goes into 55 9 times. 6 nines is 54. Subtract is 1. So my mixed number is 9 and 1/6. These are both the same number, just written differently. This form we call mixed number because that's exactly how we say it. Not as one number, but as two. 9 and 1/6. It's a mixture of whole numbers and fractions. This we call improper fractions, and we stated that that's unfortunate. It would have been perhaps better had our predecessors called it simply a pure fraction. See, this has the advantage of being a single number called 55/6, whereas this has the disadvantage of being two numbers. So very frequently we will prefer this. But then again, sometimes we need this, so we need to be able to go back and forth quickly and comfortably. So this is your math host, Bob Fennell, until the next lesson when we shall reverse that process.